Well, welcome to Astro Cafe on January 12th, 2026. We're in our weekly Zoom broadcast that is a feature online gathering of the Royal Astronomical Society of Canada, Victoria Centre. I am David Lee, and I'm your host for this evening. Is there anybody out there that's new in the audience tonight? Anybody over at Fairfield? All right.
I can tell you that my mother-in-law, Eva Bild, is here.
Oh, nice. Welcome. Okay. So the other thing I'm going to ask is we do have two presentations tonight. One about what's happening in our solar system this year, and the other one about the tilting rings of Saturn. Are there any other announcements or short presentations for the rest of the evening? Just raise your hand or put something in the chat. If I miss you, make sure you put it in the chat. I think Chris Purse will monitor for me. Oh, Jeff. Jeff, do you want to speak tonight?
Yeah, David, I've got some follow-up on Samantha Lawler's presentation, and there's a couple of other
Okay.
things I just wanted to mention to everybody.
All right. I'll just make a note of that. So Sam. So that's sorry. So that's Jeff. I think Kevin, you probably are going to make some announcements about the speaker this week.
Yes.
So I'll ask Kevin to speak. Anybody else?
I've got a couple of other announcements, AGM and such like.
All right. And anybody want to talk about, I don't know, Christmas presents or things they've received or books they've read? Anybody? You can pop in later. I'll make another call again. Okay, so let's start with our program then. And I think I'm going to start with Phil's talk. Randy, are you ready to present
I
slides?
am sharing.
All right, excellent. So
And
Philip Stooke is a professor emeritus at the University of Western Ontario in the Department of Geography. Now, he's a planetary cartographer and a historian of lunar and planetary exploration. So many of you have probably noticed the atlases that he's produced from, I think, Cambridge Press. Is that where
yeah,
they're from,
yes, that's right.
Phil?
Yeah.
Yeah,
Yes.
so he's had a lot of fun mapping. Now it's quite interesting. Joe and I spent a good time of our careers in GIS. So you, I kind of get some of the stuff. I probably have some questions for you. Um, he's been involved in searches of even crashed and landed spacecraft as well. So that's not the topic for tonight, I don't think. But yeah. So, Phil, why don't you take it from here?
Okay, thank you. Yeah, so what I want to do now is look across the rest of this year at the things that will be happening around the solar system. And then as we go through the year and these things happen, I'll say something about them at the time. So we'll get more details at the time. Let's let's go ahead here. There's lots happening this year, lots happening. We'll start with the moon. This picture was taken last year by an Intuitive Machines lander as it was coming in for a landing near the South Pole. It didn't do very well, but not to worry. They're going to try again this year, so hopefully they'll have more success. But let's go ahead. And of course, we'll start with Artemis 2, which might be the first of these things to happen anyway, and is going to loom large in Canadian news when it does happen. Chris was speaking about this very recently, so I'm not just going to try to repeat what he said, but if we just take a quick look at this diagram of the trajectory, the Artemis 2 spacecraft will be launched into a big elliptical orbit around the Earth, which is in the upper left part of that, and they will do various things in that orbit, including releasing some little CubeSats and flying in sort of what they call proximity operations with the upper stage. testing the maneuverability of their spacecraft and that sort of thing. And then they'll loop around and they'll head out to the moon, around the back of the moon. They don't go into orbit, but they'll go around the back of the moon and they'll view the far side, and then loop back and return to Earth and splash down in the Pacific Ocean off the coast of California. So that's our mission. And I just wanted to look a little bit at some of the science that will be done on it. There was a meeting last week of a NASA advisory body called the Lunar Exploration Analysis Group. And I've shamelessly pinched these slides from it. So this just shows that when they're doing the Earth orbit part of it, they'll be imaging the Earth. But then as they head out, they'll get ready to view the far side of the moon. It's the far side that's illuminated. So they'll be taking pictures of it. They'll be using their eyes for optical observations as well. One of the things they're interested in is what the human eye can see that might not be so obvious in camera images, because the human eye is very good at picking up very subtle color variations and things like that. Well, so cameras do, but they're going to behave differently. So they'll be doing some observations like that.
Do they have specific questions that they are all going to look at the
well,
window?
I think what we'd better do is look at the next slide here. So yes, they do have some specific questions. The two most important things are trying to identify very subtle variations in color on the far side. They'll be seeing basically a nearly full disk of the far side. It'll be happening when we're basically not seeing the moon at all, new moon, but they'll be seeing a fully illuminated far side. So they're going to look for subtle color variations, but also as they approach and depart from the moon, they'll have a view of parts of the Earth-facing side of the moon in darkness, and they're going to look for impact flashes produced by meteorites striking the surface of the moon. So those are the two most important things they're looking at there. And then there are several other targets and things they're going to look for.
Seems like a fairly thin science program, but
well,
they have a couple of days.
Yeah, well, they don't have a long time in that arc around the backside of the moon there. But also we have to remember that this mission is really a kind of engineering checkout of the whole system.
Which will never be used to be.
Well, it may not be used very often. That's right. So anyway, this is what they'll be looking at. There are other medical experiments they'll be doing on each other and that sort of thing as well. So we'll leave that anyway. You can see that there is a fair amount of stuff that's going to be looked at there, even though science is not the biggest part of this particular mission. Now here's something else that Chris was talking about recently, the Blue Moon Mark I Pathfinder. Well, he was really talking about, I think, the human lander that's being designed for future operations, but a smaller version of it, the cargo, is going to have its first test flight quite early this year, depending on exactly when Artemis 2 flies. It might be just before it, it might be just after it. And it's going to land somewhere near the South Pole. And this is really a test flight. Doesn't appear to be doing a great deal, although it will be using cameras to study the interaction of its rocket plumes with the lunar surface. Here's another lander. This will come up in the middle to second half of the year. A commercial lander from Firefly Aerospace, which is the one that had a successful landing last year, and hopefully they'll have another one. And this one's carrying a radio astronomy experiment. And the big thing about radio astronomy is that there's a lot of interference from all the radio chatter that goes on all around the Earth all the time. So they're going to go to the center of the far side, where they will be largely protected from all the interference from Earth. And that means they have to have a relay satellite in orbit to transmit data back and forth. So that will be in place as well. And also it will release this rover, which is from the United Arab Emirates. They flew a rover to the moon on a Japanese lander which crashed a few years ago, and they're going to have a second go at it with this mission. So there'll be some other things to look for there. This is the Next Intuitive Machines lander. They're third, and the previous two landed and fell over. So we're hoping that this one doesn't. And it's going to this rather interesting place called Reiner Gamma, a very bright spot, a sort of swirly pattern of markings on the moon in the ocean of storms. Their landing site is right inside it, and they're going to drive a rover across the pattern of light and dark markings, measuring the magnetic field and solar wind and things like that, trying to understand what's going on there and how that bright patch is formed.
Phil, it's Jeff speaking. Do you know if they've got any strategy to avoid what happened twice before with the tilting and the falling over? Is there any other ground sensing? Do you know?
I don't know. That's I suppose that's sort of proprietary information from the company. I don't know what they're doing about that. But obviously it would be extremely embarrassing to lose a third spacecraft that way. So I'm sure they're trying everything they can. Yeah, so well, we'll just have to see. But I don't know what the answer to your question is.
Okay, thanks.
Theories about why the Reiner Gamma is so magnetic.
Most likely, underneath it, there are volcanic intrusions. We'd expect them to be all over the place, but if they happen to form at a time when there was a stronger magnetic field on the moon, then they will preserve that field. So it's probably a buried volcanic intrusion. But it's not clear that that's the only thing that's going on, or even that is the answer. So we'll have to just see what the results of the mission are. They're carrying ground penetrating radar, so they can look at the subsurface structure as well. So anyway, that's something else to look out for. That'll be in the second half of the year, probably.
Before you leave that,
Sorry,
before
yeah.
you leave that one, what's the scale, for instance, between the landing site and the Reiner crater?
They're about 50 kilometers apart, I think, something like that.
Okay, so fairly close. Thank you.
Okay. You're right. I could have put a scale on there, couldn't I? Oh well. Here's the next mission. Again, probably sometime in the second half of the year. This is a company called Astrobotic, which launched a lander to the moon a couple of years ago. And as soon as it got into space, its thrusters misbehaved and they had to cancel the landing. So it's a bit of a disaster. Not a good start to the Eclipse program, but they're hoping to do better this time. And this is a different lander. This is the lander that was going to carry a rover called Viper to look for ice and other volatiles on the moon near the South Pole. And NASA decided after the last problem that they would fly Viper on another lander so that this one could have a test flight without this very precious cargo on it. And Astrobotic then was able to get another rover from a private company to take its place. So this rover called Flip is going to be tested on this mission. And it's actually the company that made that rover is one of three companies that are working to develop a human-rated rover for Artemis astronauts. And this small rover will be testing out some of the systems for the larger rover, including wheels and electronics, communications, all that sort of thing. There'll be a second rover as well, a small rover, kind of microwave oven-sized rover, that is going to be operated using Canadian software from a little company called Mission Control in Ottawa. So there's a Canadian connection to this mission as well. Perhaps the most dramatic of these landings will be Chang'e 7, the Chinese lander. It's again going to go into the second half of the year. Quite a lot of these things will be happening in the second half of the year. They have landed 4 times on the moon. Everyone has been successful. There's every reason to think this will be as well. And this one, this mission has, well, first it has a relay satellite, which is already there. It's in the upper left of that illustration. That's already in place. And then the mission includes an orbiter, a lander, and then when the lander is on the surface, it will release a rover and a hopping vehicle. And the hopping vehicle uses thrusters to jump up and then come down again somewhere else, and then again, and then again. And actually, rather than having wheels or anything like that on its base, it has legs. And the idea is that it can hop, and its thrusters will allow it to land safely, but then it can walk away to like a spider to some spot that hasn't been contaminated by exhaust gases from the thrusters, and then do an analysis. And one of the hops will be into a permanently shadowed crater. So it's going to be quite an interesting mission. And they're landing very close to the South Pole, so a lot closer than anything else has been so far, at a site that has prolonged illumination. It will be they say it will be illuminated for at least 3 months, and it could be longer than that, without any interruption in sunlight. So there'll be a lot happening with that mission, and we'll say more about it as it's happening. And I should just point out that there is already a rover on the far side of the moon, a Chinese rover, Chang'e 4, which landed in 2019 and is still operating, but it's not doing very much. It had a good start, but in the last year or year and a half, it's been only taking baby steps, tiny little moves each time. There's something wrong with it. We don't know what, but it's not moving very far. And China is not saying much about it, but there is a way of keeping tabs on it, and that is using lunar reconnaissance orbiter images. Yeah, so the lunar reconnaissance orbiter takes pictures almost every time it flies over, which is about once a month. And a couple of them are shown at the bottom there. Now, it's a little bit hard, but there's a little dark spot near the middle of each of those frames with an arrow pointing to it, and a label that says what the date of that was. And the 2 dots they're about 6 months apart and only about maybe 20 meters apart. So it's moving pretty slowly there. But it's still going. And actually, I did just hear only a week or so ago, the Chang'e 3, which landed in 2013, is still alive. It had a rover that died after 2 months, but the lander is still alive, although I don't think it's actually doing anything, just communicating every now and then.
It seems that the Chinese Space Agency doesn't have nearly the PR folk that NASA has, because I never heard of this at all.
Oh, okay. Well, there tends to be a lot of publicity at the time that the mission is getting started, and then it sort of tapers off, and you have to keep watching very closely Chinese social media and online forums that report on that kind of
I
thing.
never heard of a far side landing of a rover, so that's the total length of the path that it's driven is only 1,600 meters, so it's not breaking any distance records, but it is breaking longevity records. By far the longest operating rover on the moon. Okay, so I'm pointing that out because every now and then it does do something. And if it does something exciting, I'll mention it later in the year. Now let's leave the moon and now we'll head out across the solar system, starting near the sun with Mercury, because a spacecraft called Bepi Colombo, mainly European, but with a Japanese component, will finally make it into orbit around Mercury late this year. It was launched in 2018.
Wow.
So it will have taken 8 years to get there. And it's already flown past Mercury. So this picture was taken during a flyby on the 24th of September, sorry, the 4th of September 2024. It makes several flybys like this, using the gravity of Mercury to shape its orbit and adjust its velocity so that when they finally approach it for the last time, they're moving slowly relative to the planet, and it's not that difficult to break and go into orbit the final time. If you can imagine that if something leaves Earth and heads straight to Mercury, it picks up an awful lot of speed from the gravity of the sun as it's basically heading towards the sun. It's going way too fast for any feasible rocket to slow it down and go into orbit. So it makes multiple flybys. Bepi Colombo made flybys of Earth and Venus, and then about 6 of Mercury, using the gravity each time to shape its orbit so that it can get where it's going with the minimum of fuel. But it will go into orbit at the end of the year, and then we'll have a steady stream of news from Mercury.
I guess it doesn't need very large solar panels.
No, that's right.
Philip, is there any environmental challenges because it is so close to the sun?
Oh, yeah. It has to have a very robust thermal protection system to protect it from overheating. And if you imagine flying, if you're only a few hundred kilometers above the surface of Mercury, on the side facing the sun, which is where you're going to be if you're taking pictures, you've got the sun warming the back of the spacecraft, but reflected heat off Mercury warming the other side of the spacecraft. It's a very challenging thermal environment, so it's very carefully protected against that. Yeah.
Where did it get the cool name?
Ah, the cool name. Well, no, the first spacecraft that went to Mercury was NASA's Mariner 10. And NASA designed Mariner 10 so that it would fly past Mercury and take pictures, and then that was the end of the mission. But during a planning meeting before launch, a fellow called Bepi Colombo, actually Giuseppe Colombo, an Italian astronomer, pointed out that the orbit that the spacecraft would be in after it flew past Mercury would in fact cause it to come back and fly past Mercury again. So you could have a second flyby, as long as you just tweaked the orbit to make that work precisely. And NASA realized he was right, and they did it, and they got a third orbit as well. I mean, basically what happens is that as the spacecraft flies past Mercury, it enters an orbit which has 2 times the orbital period of Mercury. So Mercury goes around the sun twice, the spacecraft goes around once, and they meet up again. As long as you tweak the orbit so that happens precisely. So it's named after the nickname of this Italian astronomer.
Cool. Thank you.
All right. Then there's Venus, and there is supposed to be a mission to Venus launching this year, but it's not a NASA mission or an ESA mission or anything like that, but the first purely commercial planetary mission built by Rocket Lab. Rocket Lab is a New Zealand company that has been launching rockets called Electron, and it's having great success with that. It's a small launcher vehicle, but it does a good job. And they are using their profits to pay for this first purely commercial mission. And it's called the Venus Life Finder, which, yeah, what, there's life on Venus? What? Well, the thing is that a few years ago, astronomers looking at the spectra from the atmosphere detected a gas called phosphine, a molecule that contains phosphorus atoms. They uh, and phosphine in Earth's atmosphere is produced by microbes. So some people naturally said, oh, well, there's phosphine on Venus. There must be microbes that are making it. Well, of course, there are probably other ways to make it. However, this is designed to test the hypothesis that there might be microbes floating in the upper atmosphere of Venus. Somewhere in the upper atmosphere, there would be a region where temperatures were reasonable and you could survive. And it would be above the sulfuric acid clouds that would otherwise make life a trifle difficult lower down. So anyway, this is supposed to happen sometime this year. So we'll look out for that. Should mention something about Mars because there's lots of spacecraft there. There are 6 orbiters working at the moment, and another one called Maven, which has suffered a serious failure and may not survive. And then there are and 2 more spacecraft were launched only a couple of months ago to study its atmosphere, and I'll say something about them. And there are 2 rovers still operating on the surface. But just to remind ourselves that those spacecraft are not the only game in town. These are James Webb Space Telescope observations of Mars. And they get good atmospheric composition data from that and some surface composition stuff. So let's have a look now at what else we've got here. I thought I'd do just a quick look at the rovers. The Curiosity rover, which landed in 2012, is still going strong. So it's 13 and a half years from there. It's driven 36 kilometers and it's climbing step by step up a mountain slope. Passing as it goes, it passes rock layers with different compositions, and it's been analyzing them and studying basically the geological history of this area by looking at one rock layer after another as they stack up on top of each other. And this is where it is right now. Around the peculiar area, you see the landscape is made up of intersecting ridges, ridges running in different directions that make this kind of complicated intersecting pattern. It's called boxwork in geological terms. And they're driving through it. They're analyzing the composition of material in these ridges. They think that basically you had some kind of rock there originally that had cracks in it. Sediment fills in the cracks at some point and hardens and becomes harder than the rock. So then erosion wears away the rock and just leaves these this stuff that used to fill in the cracks as ridges on the surface. So they're trying to understand the process that has formed these things, and that's where they are right now. Of course, there's another rover here, Perseverance, which landed in 2021, and it's driven 39 kilometers. It's collecting samples for eventual return to Earth, even though the way that they might get returned is completely unknown at the moment, because what they wanted to do has turned out to be too expensive. Anyway, this just sort of shows its path, and the little red dots are places where they have collected samples. They collect the samples, they will cache them on the surface, and something is supposed to pick them up at some point. So we'll just have to see what happens there. But this is where they are right now. It's on the outer slopes of the large impact crater that they landed in. So they landed in a crater that might have held a lake at some point, looking at the sediments in there, climbed out, and now they're outside looking at the rocks outside the crater. And the other thing that's coming up is this mission that was launched recently in November. It's called Escapade, and I can't remember what the acronym stands for there, but it's something to do with the gases of the Martian atmosphere leaking away into space. And this will be monitoring that process and trying to understand it. Now, they were launched on the 13th of November, but this is not a regular Mars launch window. So it's very inefficient to try to go to Mars right now. But they wanted to get them off the ground. And these things are loitering at the Sun-Earth L2 point, a little bit beyond the Earth from the Sun, for about a year. And then they'll make an Earth flyby and gravity assist that will take them to Mars. So
L2 is where Gaia and Webb are living.
yes, that's right. But there's a lot of room out there.
Okay.
Yes, that's right. And something else that's coming up, this is going to be an interesting mission, launching late in 2026, MMX, the Mars Moons Exploration. It's a Japanese mission which will land on Phobos, the moon of Mars, and collect a sample and bring it back to Earth. Japan has already done this with an asteroid, with 2 asteroids actually. So they're just launching at the end of the year, and it will be the following year before they arrive. But that'll be a very interesting mission when it gets going. And also, I ought to mention this, a mission called Psyche, a NASA asteroid mission, which is on its way to a metal-rich asteroid called Psyche. It will make a flyby of Mars for a gravity assist and use Mars to calibrate its instruments, especially its magnetometer, before it gets to this interesting metal-rich asteroid that it's going to. So a Mars flyby in May. Now there's some asteroid missions. In June, China is sending an asteroid mission, which is already in space. It launched in May of last year, and in June of this year, it will arrive at that asteroid, whose name I prefer not to attempt to pronounce. But it's the reflection spectrum of this asteroid suggests that it's the same composition as the moon. So it may consist of ejecta thrown off the moon by a big impact, which would have spread out into Earth's orbit and then collected together, clumped together to make this little asteroid, which is only a few hundred meters across. But they're going to bring back a sample of it. So it's a sample return mission that will arrive in May. Not the only game in town. In July, a Japanese spacecraft called Hayabusa 2, this is the one that collected a sample from another asteroid. It brought the sample back, dropped a sample container into the Earth's atmosphere where it was successfully recovered. But the main spacecraft flew on past Earth, and it's going to fly past this little asteroid called Torifune. So we have a new asteroid flyby coming up in July. And then at the end of the year, a European spacecraft called Hera will arrive at an asteroid called Didymos, which has a moon called Dimorphos. Now, this is the asteroid and its moon that was visited by a NASA spacecraft called DART in 2022. DART, which was the Double Asteroid Redirection Test, I think that's what it was called. It was an attempt to see if we can deflect an asteroid by impacting something into it. So if something was discovered on a collision course with Earth, the idea is you would fly up there and bash it with something that would just knock it that little bit off course so that it would miss Earth. So this was the test of it. And it did change it didn't hit the main asteroid, it hit the little moon, but it changed its orbit. So we know that the process works in principle and lets us kind of calibrate what you'd have to do to deflect something dangerous. But this spacecraft is going to go to that same little asteroid and moon system and survey them in detail and understand exactly what it was that the impact did to that little moon. So it arrives in December, and over the course of the following year, 2027, we'll get results from that.
So it will be forever in orbit around
Yes, it's orbiting.
Didymus.
Yes,
Wow.
it's orbiting. And this is where I'm going to end at Jupiter, because there isn't anything really happening further out that I want to mention. There's a spacecraft called Juno, which has been um, uh, orbiting Jupiter for several years, mainly studying Jupiter's gravity and internal structure, its clouds, its the way heat is distributed in the atmosphere, its auroras, all sorts of things like that. But it has also flown past some of the big moons. This particular moon is Io, or Io, the volcanic moon of Jupiter, which is a bit bigger than our moon and covered with active volcanoes and sulfur deposits and stuff like that, which is what makes the funny color there. A very peculiar place. Now, Juno is still there and it's still working, but its primary mission ended quite a while ago, and the extended mission it was in ended at the end of last year. And we don't it's not very clear what's happening to it. I haven't seen anything talked about, but it may have been the victim of budget cuts. So we don't know yet. But I'm waiting to hear what's really happening with it. And also, there are two spacecraft that are actually on their way to Jupiter, JUICE and Europa Clipper. JUICE is the Jupiter Icy Moons Explorer, and Europa Clipper, and they're both designed to primarily study Europa, although they will also study other moons. And they're both on their way to Jupiter, but they're going to make gravity assist flybys of Earth on their way to Jupiter. Both of them happening in the fall of 2026. So we'll see these two spacecraft buzzing past the Earth, taking pictures of Earth and the Moon probably to help to calibrate their instruments before they go out to Jupiter, where they'll arrive in a couple of years. So I guess that's my...
Wow.
That is my last slide. Yeah, okay. Yeah, there we go.
Well, that's great, Phil. I wonder if there's questions out in the audience. I do have one, a quick one. You mentioned a lot of kind of commercial contributors to these missions.
Yeah.
Is there kind of like an up-to-date list of all the people that are active right now and maybe what their motivations are?
I don't know. It's not always obvious. If you take the CLIPS program, the Commercial Lunar Payload Services program that is flying experiments to the moon on behalf of NASA and anyone else who wants to send them, there are 4 companies that have won awards to do that. Some of them have won multiple awards, but there are another group of companies which haven't been successful, and some of them I know are defunct, but they don't necessarily publicize when they're not doing well. So I don't really know exactly which ones are still operating.
So is it, Phil, is it possible that a lot of people participate just to see if they will make it? In other words, they're not going to say anything a lot just in case they don't, right?
Well, I suppose. I mean, it's
Yeah.
a complicated situation.
Yeah.
I keep up with the ones that are successful, but I can't keep up with the ones that are not.
Okay.
So words from who?
Oh, well, NASA. So
From
the CLIPS program is operated by NASA, and the idea is, let's say, well, for the Firefly mission that will go to the far side of the moon in the middle of 2026, NASA is flying a radio astronomy experiment, and they're flying several other experiments as well. But the CLIPS supplier is providing the spacecraft. They can also pick up payloads from anybody else who wants to fly them, as long as they won't interfere with the main mission. So in that case, NASA's flying its radio astronomy experiment, but the United Arab Emirates is picking up some spare payload space to put their rover on it. And So it's a combination of things. Basically, NASA is the principal customer so far, but I know that in a couple of cases, these companies are attempting to put together a purely commercial mission, and they just haven't got it together yet.
Hmm. So for the people that just kind of tag along, do
Oh,
they provide monetary resources to it?
so, well, yeah, NASA does. NASA pays to fly its payloads.
Right.
So I mean that's a commercial arrangement. But um, uh, NASA would also like to be not the only game in town. They would really like to have these companies more self-supporting and able to pick up payloads from around the world, anything that other people want to send, so that NASA isn't always on the hook for funding the mission.
Hmm. That's a good comment. Okay, is there any other comments or questions for Phil? If not, I think I will maybe shift to some announcements before we get to the second talk.
Well,
Um,
thank you very much, Phil, first.
Oh, thank
oh,
That
you.
was
okay.
fascinating,
Yeah, excellent.
absolutely fascinating, and a lot of work went into it. Thank you.
Yeah, thanks.
Yeah, most definitely. Jeff, I've got you on the list here. I don't know what you're going to talk about, but please take the floor.
Okay, thank you.
Oh,
Super. Just a couple of things I wanted to mention first, before I actually get into the bulk of what I wanted to talk about. Um, it, my last astronomy magazine arrived in October, and I really didn't think too much about it. But when I didn't get one through September, I phoned them, and it seems that Astronomy Magazine is no longer sending the print copies to Canada or to other countries outside of the States.
Oh,
Uh,
just an American only publication now.
yeah, well,
Wow.
yeah, they provide the digital access, but they're no longer providing the print. And there's a bunch of reasons, and it's kind of hard to pin them down actually, whether it has to do with the tariffs or whether they're losing a lot of people subscribing to the print copy because they use the digital copy, or whether there's other internal factors. But just FYI for everybody, if you think you're going to subscribe for Astronomy Magazine, you won't get a print copy. It's only the digital copies arriving now. And I found that there's digital copies also available at the library. So if you have a digital access to the library, you can get your digital copy that way.
Hmm.
So just an FYI, that just occurred to me to inquire with them. Second thing I wanted to just talk about for a second, and I just got a notice about this, so I wanted to bring it to attention. The VSO, the Victoria Symphony Orchestra, has a series of concerts, and one of the more colorful conductors is Shauna Loughlin, who does a lot of their pops concerts and a lot of other really interesting concerts. He's a very connected fellow. They're doing a concert that they're calling the Planet Symphony in Space later this month. I know there's still tickets available because I just got a note, saying there's tickets available. Their advertising says the Victoria Symphony brings you music out of this world, but they're doing selections from Richard Strauss, also Sprach, Zarathustra. Holst has a symphonic suite, and they're doing three of the selections: Mercury, Mars, and Jupiter. Mozart has a symphony called the Jupiter Symphony, and they're just doing the finale from that, and then Johann Strauss with the Blue Danube, which I think everybody knows from 2001. And then there's a bunch of selections from Star Wars. He's quite connected to the movie industry also, and I think he knows John Williams personally. So there's quite a bit of stuff he's able to get up through from John Williams. They're doing some selections from Apollo 13 and also some Star Trek selections. So if anybody's interested, that's the Victoria Symphony Orchestra.
Hey, thanks, Jeff.
The other thing I just wanted to mention, just crossed my desk a couple of days ago. Actually, it was on CBC January the 8th, and Times Colonist reported it January the 10th. And I've subsequently talked to Chris Gaynor about it. For the first time in astronomy history, NASA's bringing a space mission back early because of medical issues. One of the astronauts on Crew 11 has a declared medical issue, and they have to bring him back. So Crew 11 was supposed to stay for 6 months. They're coming back in 5 months. So a couple of weeks early. Um, Unspecified, of course, who the crew member is, and it really doesn't matter, but it's privacy. The interesting thing from my perspective is what is the medical issue that's bringing the crew back? More in that it's impressive that they can bring somebody back from low Earth orbit. It's going to have implications for longer missions where you can't bring somebody back. So, there is going to have to be a way to deal with this kind of thing arising. And certainly there are mechanisms that they're looking at. In fact, I'm putting together a presentation for a future Astro Cafe on medical issues that arise in space and ways of dealing with them.
Well,
Um,
that's excellent, Jeff. I that makes me think of something I saw on CBC recently, where they talked about uh, what would happen if there were little emergencies, like people cut themselves or whatever. But apparently, they're training them to do, very simple procedures, which makes sense, right?
Yeah. No, cross training exactly. And then there
Yeah.
are lots of that. Interesting. When I was talking to Chris, he said it hasn't arisen in the American space program before, but he believes it did arise in the Soviet space program, where one of the missions had to be terminated because he believes that one of the astronauts was suffering from acute prostatitis.
Right.
So, like medical issues, the stuff that we have here on Earth can arise in space, and there have to be ways to deal with that as well. Chris,
Jeff,
yeah, yeah.
Jeff, there was the whole thing about one of the Apollo 13 astronauts was incapacitated with the flu or something.
I believe he was exposed to either a viral bug or possibly to measles before the launch. So his replacement was subbed in. He never subsequently developed it, but yeah, they had to be aware of that. And that was part of the whole quarantining of astronauts before their flights, just to make sure that there was no viral exposure.
Yeah, I think CJ has a question.
Yeah, yeah.
CJ?
Go ahead.
Yeah, for the Apollo 13, it was Jim Lovell that actually replaced. I can't remember the one that's supposed to had. It was they had some doubt that it would get chicken pox or something like that, and so they pulled him out of the mission and they replaced it with Jim Lovell. And throughout the mission, Jim Lovell had a bladder infection, but he didn't say anybody. He didn't say anything. He came back with like a 40 degrees Celsius fever and toughed it out all the way back. So yeah, double medical emergency. One that
Actually,
saved.
it was different people. So Ken Mattingly was on the original crew,
Yeah, Mattingly. Yeah, that's
and
right.
he was bumped off because of this chicken pox exposure, and uh, uh, and Jim Lovell and Fred Hayes were okay. They'd been exposed to it, and so Jack Swigert replaced Mattingly on Apollo 13. And by the way, Mattingly got to fly in Apollo 16. Uh, and during the flight, Fred Hayes developed a urinary tract infection, which I think was kind of due to the fact related to the conditions they had in there, where I can't remember if water was in short supply or they had to hold it in or something like that. he didn't actually really get sick until I got back, but yeah, he was able to do his job in the flight anyway. He probably wasn't feeling that great. So anyway, that
Interesting.
that's what.
Thank you for clarifying that, Chris. That's interesting in that it obviously implies, the necessity for them to talk about what's going on, to be able to test for it, and then to be able to treat it in longer duration flights, because you won't be able to come back for antibiotics. So Chris had also sent me this picture just, I think it was just earlier today. This is the four astronauts going down. So the transfer of the commander, because one of the fellows going back was the commander of the space station, to one of the three people remaining. So what I wanted to talk about a little bit came off Samantha's talk last week. It was very interesting. She was talking about primarily Starlink and the risk of collisions and crashing to Earth or falls of the satellite. So I did a little bit more digging about it because I really, it was apparent from her talk how little I really understood about it. And the more I read, the more complicated it became and the more rabbit holes there were. So I'll try to keep it brief, but it was very interesting, and I wanted to just share some of that with you. So the current status, I'm going to try and get this out of here. The current status, firstly, of the current and the projected number of satellites, both now and by the end of 2006, is pretty massive. Um, with Starlink, which is the biggest contributor, there's about 9,500 functioning now, and they're looking at having about 12,000 functioning by the end of this year. Amazon is starting to make moves into the space satellite area. 200 up now, 1,600 by the end of 2026. Both of these are really broadband, although SpaceX or Starlink is going to be looking for mobile connectivity as it gets into some of the more advanced Starlink versions. Eurosat, Utilast, Eurosat is the European commercial version that's looking for doing broadband, some defense and government communication, and also some mobile communication. It's a private company which is publicly traded. France and Britain are their major investors. China has a satellite series going 300 now, looking at having 800 in space by next year. It's for broadband and also for quotation marks strategic national interests. There's some smaller ones. There's a private Texas company that is called AST Space Mobile, has about 20 circling now and 60 by the end of 2026. They are a small commercial venture, and they have deals with some of the major U.S. cellular companies to provide coverage. And then there's Planet Lab, which is trying to provide accessible information for monitoring global change. They have about 200 up now, and I couldn't find any information about what they were, whether they had any projected launches or whether they're going to keep any of them in orbit through 2026. One of the other things that was really interesting, I thought, in Sanders' talk, and it was certainly something I wasn't fully aware of, was how how the satellites were able to maneuver to attempt to avoid running into each other. And this is obviously going to become more of an issue as there's more and more satellites in space. I mean, when you're talking, three or four, space is huge. When you're talking 15,000 in reasonably controlled near-Earth orbits, it's a little bit more of a risk. So the very early satellites, the CubeSats, could maneuver a little bit to change their facing profile, increase atmospheric drag, allowing to shift somewhat their orbit. Some of the newer satellites, of course, have onboard thrusters. Some of them were controlled from the ground. But the more advanced ones now, Starlink certainly has autonomous control of the collision avoidance systems. It's actually the way the systems work is that the um, maps of what's in orbit around them are continuously updated from the ground. And then the Starlink system itself is able to use AI to make autonomous decisions about its orbit and what may be in the way. So it's able to theoretically maneuver long in advance, so with small course corrections to avoid to avoid collisions. I think that Samantha alluded to it, but this or the past year, 2025, they performed up to about 144,000 maneuvers to avoid collision risks. So, and that's going to become more as there's more and more satellites in space. So the satellites work with about a 5 year. No, we're talking primarily about the Starlinks now. Work with about a 5 year operational lifespan. They have some really neat sounding propulsion systems, which is a electromagnetic um, a system that can direct ionized stable gases in um, high velocity beams so that they can prolong course changes without using a whole lot of the gases that are stored. The estimate is that they can actually make about 5,000 course corrections through the lifetime, and specifically about 350 orbital avoidance maneuvers. It's unclear of the 144,000 whether those were considered orbital avoidance maneuvers or just course corrections. But I'm sure that there's a criteria they have to log those. Again, 144,000 maneuvers last year. The satellite types, the Starlink continues to update, and I'll go through them with a little bit more detail. But basically, they started with, of course, version 1, then version 1.5. Then they came out with version 2, but they needed the larger rocket to fly it. So because they only had the Falcon 9 to this point, they developed a V2 Mini, which is bearing the majority of their satellite load at this point. I think the original version used xenon gas, the V1 and V1.5, which is all part of the version 1, used krypton. And now V2 Mini, and what you'll see is going to be the projected V3 is using argon. Argon gas is considered more effective, I suspect, because it's lighter, but they have a more robust thruster system with with the electromagnetic thrusting system. So they're certainly working towards efficiency.
What is the Hall effect?
It is where do I refer to that? You're talking about the Hall function or the Hall effect? Yeah. That's the name that they give to the thruster system, the electromagnetic system. So basically, they direct through a magnetic beam ionized inert gas. That's the name of the thruster, the Hall effect thruster.
So this is an ion drive, as we used to call it in science fiction.
Yeah. Yeah.
Well, I would it certainly uses ions. I'm not sure if that was what the ion drive was designed to be, but yes, this is the current version of the ion drive. So just quickly through the different versions, V1 was launched. 16,665 of those were launched, of which 156 is still in orbit. The remainder, or the majority of those, have been deorbited. I suspect that the one that Samantha found was one of the deorbited version 1 satellites. 1.5 was then launched. They've had about 2,900 of those up. They're larger, of course. Each version gets larger than the one before it. The first version, version 1 and version 1.5, just had a single wing for the solar panel. Version 2 and version 3 are going to have a double wing, and I'll show you a picture of those when we get to it. So basically, 1.5 had about 2,900. Version 2 Mini, which is the majority of the functioning Starlinks in orbit now, is 6,100 of them have been launched. And then version 2, interesting, is really awaiting for the Starship to launch it. And most references I read said that none had been launched, but I ran across one that said 38 of them had been launched as a test on a Falcon 9. So I'm not really sure, what the real status is. I know Falcon 9 launched a couple of test versions, and also some of the very early starships also carried some test V2s, but I don't know if they were functional. Chris, do you know if any of the V2s are functional currently?
You know, uh, none of the starships have really gone into orbit, and in the past year they launched some with a dispenser for these satellites, and those were the ones. There was a couple of them that just blew up on the way up, and the last one successfully deployed uh, some uh, some some of these things, but I actually don't think they went into orbit, and I think they were actually dummies.
Okay, that was the test
My
one.
memory serves me right.
Yeah. Oh, okay. That certainly fits with the majority
We
of them.
did see a spray of what must have been a launch from the V2 at some point a couple of months ago from our porch here, going from roughly the vertex to the northeast, a spray of uh, points of light that gradually separated. And we were told that this was the offspring of one of these uh, uh,
Starlink.
firing to send up a whole bunch of um, uh, small
Sure.
orbiters, small
So
satellites.
yeah, I
That there was a clear group which was gradually spreading apart.
yeah, that's
Mhm.
pretty amazing the way they go up. I suspect if it was 2 months ago, it was probably a V2 Mini launch because
Yeah.
that's the majorities that have been. I mean recently. Um, what they do with the others, and I've got a slide I think with how many are still up, is try to deorbit them. So the 15,000 that we projected, actually it was 12,000 of the Starlink is meant to be the functioning Starlink. They tend to deorbit them. Certainly when they become non-functional or at the end of the lifetime, or I think the early versions, well, the majority of them have been deorbited. So this is really the comparison. This is really what they look like. Version 1 is a smaller image of version 1.5. It's basically, the core functioning part of the satellite with a single solar panel. They developed the double solar panels with version 2, version 1.5, or version 2 Mini is just a smaller version of 2 with a double solar panel. Version 3 is much larger, and it's going to go up from there. There's a projected version 4 already. So it's getting bigger and bigger, and certainly much more capacity with each satellite. So just to quickly go through, and you can see the size change. The original version 1 weighed about 260 kilograms. It was first launched in May of 2019. That is the first satellites go up. They go up in groups, as was alluded to. It's not just one satellite with each launch. 1.5 was launched in September of 20, or started being launched in September of 2021. It was about 300 kilograms in weight, so reasonably comparable size. Both had single solar array. They have avoidance even from the early version. There was a autonomous avoidance system. The avoidance systems also became better, and you'll see the capacity of the satellite as it gets larger. 1.5 had a capacity of about 24 gigabytes per second per satellite. When you get into the second generation V2 Mini, which started being launched in February of 2023, it weighed about 800 kilograms. It was using the argon gas, two double solar panel, and capacity was about 96 gigabytes. The full version, sorry, the full version 2, which still is waiting for the Starship, is going to be about 1,250 kilos, and it's got a capacity of about 240 gigabytes per second.
Oh, or is this increasing size related to a reduction in the eventual number of the satellites?
Very good question. Certainly, the increasing size and the increase in solar panel is related to the increase in capacity. Whether the increase in capacity will result in fewer satellites or not, I think is TBD. I mean, I hope it does. It would make sense it does. But if there's more demand for it, then the answer is no. And I think it's truly uncertain at this point. I suspect because there's so little regulation at this time that determines what can go up. I think it's really a marketplace thing. Does anybody else have any insight into that? Okay, so launch masses that we talked about. Different gases for maneuvering, starting with a single wing, going to a double wing. The launch vehicles, the Falcon 9 launches up to the Mini, but really the Starship's needed for V2, and then V3 is the next version coming. It's going to weigh 2,000 kilos, and the capacity, the operative capacity increases. As does the size and the ability to generate more electricity with the larger solar panels.
And all of these are designed to burn up upon reentry.
So if you read the literature, yes, they're intended to, but you'll see when we come to the problems, you'll see what what some of the issues are. Interesting in what I was reading about reentry, they referred to only one known Starlink, which came down in Saskatchewan, and all others burned up. So I mean, we had that discussion with Samantha. Whether that's in fact the case or whether they just came down in uninhabited areas or in the ocean. So
I just can't understand how a 1 or 2 ton satellite is going to burn up.
I'm with you, especially as they get bigger. And that's one of the issues, as you'll see, although there are a couple of others. So anyway, the plan is this is the projected planning for SpaceX is to have V3 operating as the main satellites in the Starship. And I think if they still have 1.5 or 2 still operating, I don't think they're going to deorbit them until they've used up their lifetime. I mean, I just think that would be, a waste of their money. They're continuing to use the Argon propulsion system, which seems to be efficient and is becoming the standard for low Earth orbit satellites.
Well, when they're going to deorbit them and let them fall, perhaps they should put a tiny explosive charge in them so that they blow apart, and then
Sounds like a great idea.
the fragments would burn up more easily than a ton.
Well, it's an interesting idea. I wonder, there would be the question of safety launching it. But I think there's a lot of TBDs here, and it's a real it's a real new frontier, and I don't think a lot of the answers exist. It was one of the things I picked up from Samantha just in terms of her frustration with the lack of any kind of regulation or control, and just the open field on doing this. And I certainly, as I went through this, and as you'll see as we go a little further, um, it's pretty interesting in terms of the open field here. So,
But it is a race, right? Like
oh, it is, and it's the
if
technology.
Elon can get capacity up there, then no one else can justify putting their capacity up there, and he'll have the market on the infrastructure.
Well, I think he'll have the market. I think that there are people trying to, get up in competition. I mean, Amazon looks like they're starting up, but you're right. I mean, he's got a huge foothold. And I've got to tell you, the engineering of these things is amazing. I mean, and it really does provide connectivity. The problem is, the downside risk. And it's always a trade-off, which is why I think some regulation in the field is needed. So let me just walk you through a couple more slides, and then we'll be finished. So what's the concern? We're going to have more than 15,000 satellites in orbit by the end of 2026. I mean, you all know the issues with just the difficulty with any kind of astrophotography with that. There is also the increasing risk of satellites colliding, especially when the satellites are from different manufacturers, and I'm not sure what the information sharing is like. I mean, at this point, the vast majority are Starlink, and they do have some communication between the satellites, as well as ground-based monitoring and uploading of the nature of traffic at various orbits, which is what's read by the autonomous controlling system and then filtered through AI so that they can make course corrections. So this is where I started to become, there's lots of uncertainty here. So by late 2026, Traffic Coordination System in Space, TRACS, which is the acronym, is supposed to be developed by NOAA's Office of Space Commerce. This is NOAA, the National Oceanic and Atmospheric Administration, the one that's been suffering all of the budget cuts under the U.S. Department of Commerce, and is expected to fully take over civilian space safety data from the military. And then we'll be introducing a fee-based premium safety system well, it was 2025 at this point, and it's not developed, so it'll be 2026 at the earliest. This system is being developed to implement President Trump's direction in Space Policy Directive 3 for the Department of Commerce to provide space operators with space traffic safety data and services free to direct users. That is as of a directive in 2028, with a modified proposal to monetize it in 2025 for third-party providers in order to offer value-added commercial services. So, I mean, it sounds a lot like the Trump administration. The Trump's direction of Space Policy Directive, so Space Policy Directive 3 is a real motherhood statement, basically asking NOAA to develop a very comprehensive control system. So this is what SPD3 is supposed to do: create a comprehensive system for managing space traffic, including better tracking, situational awareness, improve the ability to track objects in space, implement updated guidelines for satellite design and operations to reduce space junk, encourage growth in the U.S. commercial space sector by providing a stable framework, work with other nations to promote safe, responsible space behavior. It really read to me like a motherhood an apple pie sort of statement, like, do all this stuff and do it quick, and we're not going to give you any money.
Mhm.
So anyway, it's very interesting. So the other real concern about this stuff is just with this number of satellites, they're projecting that 3 to 5 of them are going to be deorbited daily through 2026. So there is an increasing concern about the accumulation of metallic aerosol in the stratosphere, and that's primarily aluminum from vaporized hulls of the satellites. So they vaporize, they enter at high speed. I mean, because you want to burn them up. There's ablation. They burn up, but there's some ablation. The aluminum's turned into a mist of nanoparticles. Most of that happens at the upper atmosphere. It takes a long time to drift down into the stratosphere, which is where the ozone layer is. Um, and what their sort of pen and paper projection is that a 250 kilogram satellite is going to generate about 30 kilograms of aluminum oxide. Well, the satellites are going to be more like 2,000 or 3,000 kilograms, so there's going to be quite a bit more aluminum oxide. And if it's going to be the smaller ones initially that deorbit, but there is going to be, if this proves to be true, there'll be an accumulation of an aluminum mist nanoparticle in the atmosphere. So what's the implication of that? Well, the biggest concern is ozone depletion. Um, the nanoparticles are a catalyst for some of the chemical reactions that will help destroy the ozone layer, and may go on for a period of time. The other concern, and this is more in the research, is just what the effect of a aluminum nanoparticle layer in the atmosphere is in terms of both affecting incoming sunlight and absorbing outgoing infrared radiation, in terms of raising Earth temperature further. So there was a projection that with this, it could potentially go up by about 1.5 degrees in the first pass. There are some questions about how that'll change the albedo of the Earth, affecting obviously the sunlight hitting the Earth. So with that,
Yeah, for sure, there's a lot of Chicken Little skies falling
well,
stuff being
there,
claimed out, but
well, I don't,
you've
I
got to
don't
look at the benefits to humanity of having internet, and an example is what's going on in Iran right now. Like,
I think you're absolutely right. I think the technology is amazing, but I think the approach needs to be anticipate what the potential problems are so that you can mitigate them, not dismiss them. And I think that's really important. I mean, I think that's also going to be part of the whole issue with the medical issues in space. I mean, there are a vast number, and you can interpret it as little, but I don't think it is. I mean, I think we need to go forward. This technology is amazing, but I do think there has to be an approach to mitigate it.
I think it's profoundly depressing. Thank you very much, Jeff.
This talk comes with a little bit of scotch.
Yeah.
Well, it's yes.
Well, thank you, Jeff. Actually, a little side topic turned up at the beginner's sig at the beginning of the month, and I'll add this to the chat. Doug Hardy suggested a book called Space Hazards. So if that wasn't enough, here's a book about kind of natural hazards. I think like solar flares, asteroids, et cetera, et cetera. So I'll just add that to the chat. But yeah, I think there's a lot to think about, and there will always be this challenge between advancement and risk, and I don't know where it will go. Um, Obviously, if you don't move forward, you just stay static. So probably not a great solution. But Jeff, that makes a lot of sense that we're not necessarily want to stall, progress, but to mitigate anything that we can possibly do.
Yeah, that was
Great,
certainly.
thank you. Um, Randy, I think before we go to you, I think I'll just get Kevin to do a quick announcement for the monthly meeting, and then we'll go to you.
Okay.
Kevin?
Thank you. So on Wednesday at UVic, our talk will be entitled Discovering Worlds Beyond Our Sun. It's at UVic, Bob Wright Center, Lecture Theater A104 at 7:30.
Which Wednesday?
This Wednesday.
Oh, okay.
So it's all about the Andrew McKellar 1.2 telescope on at the Dominion Observatory, and it should be very interesting. I understand
Yeah, it should be really good. I mean, for those of you who don't know what that is, there's that little dome before we get to the VCO, before we get to our observatory. That houses something called a Coude spectrograph, and that's part of the topic for the speaker. So
I've had the opportunity to actually be in the spectrograph. It is not a black box. It's a room with these pillars and these mirrors and things, and you can actually walk in there. They never let you do that because just your heat takes like a day for it to calm down. But I was with a bunch of science fair kids, and they allowed us to walk inside the spectrograph. It's really cool.
Yeah. Yeah, you can certainly Google Coude. I mean, there's quite a number of devices that are based on that kind of principle. There's one down in Arizona, in fact, down at Kit Peak that I got to see. I never got to see the insides, but it was a Coude style.
Yeah, we
And
were told this was one of the only tours they've ever let inside it.
well, that's amazing. That's amazing. And spectroscopy, as you'll find out in the talk, is pivotal in all the discoveries that we've made. Oh, Lauri.
Yes, I was just going to say it's called the McKellar telescope, and there's going to be I believe is it the niece of McKellar is going to actually be there at the meeting. Is that correct?
Either the daughter or the granddaughter. I'm not sure.
Oh, sorry. Okay.
Yeah.
Is going to be at the meeting, and I believe she may have a few words as to why it's
Well, that would be nice.
why it's named after her relatives. So come and find out more.
Yeah, absolutely. Absolutely. And hopefully, I think, oh, there's some hands at Fairfield, please.
Thank you, David. Just before we go on to Randy, I just wanted to thank Jeff for summarizing that stuff, going through all the rabbit holes. It was really interesting and terrifying. But I think there's a commercial opportunity for a fundraiser for RASC Victoria. I think we should buy in bulk and market Starlink hard hats.
Little antenna.
Yeah.
I like that idea.
Make them pointy out of tin.
I won't buy one. I'm going to recycle my Skylab hard hat.
Great.
Yeah.
So
David,
go ahead.
Just to follow up, it's Andrew McKellar's daughter who's going
Right.
to.
Oh, thank you.
Okay, daughter.
Thank you.
Okay,
Name
there
is
you go.
Barbara Bullman Fleming.
Okay, well, there we'll see somebody who knew part of DAO history.
I think she knows quite a bit. I know her fairly well, and
Oh, okay.
so actually not so much, not really through astronomy, but she's quite active, like Jim Hesser in the music scene. And
Oh, wow.
so Audrey and I see her at a lot of events.
Okay. That sounds great. So Randy, I think you have the floor. You've got some announcements.
Well, I'm going to continue with announcements first.
Okay.
So Astro Cafe next week. Jeff has volunteered to be host. That is the 19th. And then 26th, I'm still looking for a host. And then the 2nd, looking for a host, but in particular, it's going to be help me, Dave, I'm just blocking his name. Alistair Ling is coming from Edmonton.
Oh, he's in town, eh?
He will be on the 2nd.
Oh, cool.
Dave, do you want to host that day?
No, thanks.
Oh.
I'll probably be feeling the effects of the beer that I've had. Alice.
Oh, okay.
Yeah.
Anyway, but very important is, first of all, today is Monday. On Thursday is the last council meeting before the AGM, which will be on February 9th. So there's a bit of planning and such, but it's an open meeting, of course. And there's an email from Dan Posey with the information. And so on the 9th, there will not be Astro Cafe, and it will be online only, so that Chris can do his magic so we can do our votes. And then 2 weeks after that will be the 23rd. We're having our social evening. And I think it would be very clever if I use that as the opportunity to get t-shirts, the RASC t-shirts printed. So we have some of the smaller sizes, but I neglected to make enough large sizes last summer. But these are all going to be by order only. And I'll send out an email. But if in the email, I'll say what are the sizes that we have. But if you want a different size, the extra large 2X, the company will make them, but I better order them before the end of January so that we have them by the 23rd of February. So there'll be an email, but you can also just email me, pastpresident@victoria.rasc.ca, with your order, size, and the color. I think it looks better with the dark colors, the black, the dark blue, the dark green. They can make any color. If you want to make it white, it would look dumb, but there you go. Are those all my announcements? Yes, Lauri.
I was just going to say that I will have a sign-up sheet for the dinner going at UVic, and I will give more information out there. Please come. We need about 55 people in order to be able to get the room. So we're hoping that
So
everybody will
actually,
come.
early RSVP is better, isn't it? So that we
Oh
know we
yes,
can make it. Yeah.
absolutely. That's right. Yes, if you know that you're going to be able to come, then please do bring a friend or an enemy, as the case may be, whatever you'd like. But we'd like to have we need about 55 people there or so for us to have the room. And I can send, maybe what I can do is by Wednesday I can have a bit of a menu for people, or things like that, so that you can have a look at that. We'll go on from it. I think we can prove the same thing that we did last year was the any coffee and tea and things like that will be on the RASC credit card. So we'll let people have that. So okay,
Yeah.
thank you very much.
That sounds
But this
great.
does
Thanks, Lauri.
remind me that we will hand out the awards then. But we haven't started talking about choosing our award winners, and especially our photos. So make sure that your photos from 2025 are in Zenfolio. If you don't know what that means, talk to, I guess, Joe. And if you want to volunteer to assess the photos and help with the decisions on awards, contact me. But we got to get working on that. We have to have decisions made by February 9th, which is going to come really fast. Okay. Is that it for announcements, or?
I think so. I don't. Last call for anybody who wants to say
I just
something.
have a couple of little announcements
Okay.
just about spacey things. Just following up on Jeff's excellent presentation about the crew returning to Earth. They are coming back on Wednesday night, a little after midnight. They will be landing back on Earth, back in the Pacific Ocean in the middle of the night over there. But NASA, uh, there's YouTube and NASA. There's lots of coverage if you want to watch it.
So what time would that be, Chris? In our time, local time,
It's like I said, after midnight.
just after. Okay. So
Like
keep watching.
I can't remember 12:30, 12:49.
Okay.
And the separation from the space station is earlier in the day. Um, but that'll all be posted online somewhere.
Hmm.
Um,
Sounds good.
and the other thing is Artemis will probably be trundled out to the pad on the weekend. And that's something that takes several hours, but there'll be lots of great pictures coming down of that, and it's just a sign that that launch is getting a lot closer. And another thing was last night on the National, they had a feature interview with uh, 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 Hansen,
Jeremy Hansen.
Jeremy Hansen. I was going to say
Hmm.
Jeff. Jeremy Hansen, and it was quite an interesting interview, which actually touches on some of the stuff that Jeff was saying about um, you know medicine and these sorts of emergencies in space. They were talking about some of the training that the astronauts get. They learn how to do. Uh, uh, Hanson was saying that they get to spend time in the emergency room, and they
Hmm.
actually learn how to stitch people up and stuff like that. And I know for a long time they've got some training about dental procedures and things like that. Um, and also talks about kind of the dangers you deal with up there and the possibility you might not make it back.
Yeah, I was quite touched by his comment about preparing his family, right? And the fact that he recognizes the danger, but they've done everything they can in terms of preparing the family for particular outcomes as well.
Yeah. So a lot of that is online. I think they're going to
Hmm.
put the whole interview online, and they'll probably be repeating it, when they cover the mission, which could happen as early as February 6th. So that's what I have to say.
Laurie, did you still have a comment?
Yes, I just wanted to remind people that on the 17th, which is this coming Saturday, we are having a special star party. It's the annual games night uh, at the center, and I am rounding up people to be on the team. So you may get a phone call or an email. Just um, we need some really kind of fun competitive people to be on the team to see if the RASC can beat the FDAO at
Good
their on
faith
their own
then.
turf. So for
We
games
need
night. So
faith
please come along. It might be, I think if they're actually even saying that might actually even be a little bit of some clearing, possibly. I don't know, maybe it's changed in the last day, but we may be able to even throw out a telescope or so on that night as well. So please come along. It should be really fun.
That's
Will there
great. Thank
be
you.
anybody up there who can tell us what we see if it actually does clear?
Um,
Let's
you'll
put
be
it
able to
that
do
way.
it, Chris. You'll be
That's
able to do it.
the
I don't know.
smart
It's been so long.
the smart telescopes will tell us. The Vesperas will tell us.
Yeah, there you go.
Anyway, sorry guys, there we go.
Okay, so next up is Randy. He's gonna give us an explanation of the ring crossings we had last year and the tilt of the rings. and all illustrated by our astro imager, Brock Johnson. So take it away.
I promise no spaceships. This is all stuff from the ground. Okay. Yeah. So last year, the image of the year was a bit of a cheat because it was Brock's picture that it took him 5 years to take this picture, and I asked him for the dates of the of when he took these pictures. And by the way, Brock, you got them wrong. I went to your Zenfolio. These are the correct dates that you took them. And so the very obvious thing is as you go through the years, we're looking at Saturn with a different aspect, and it's getting shallower and shallower and shallower. We're seeing those rings edge on, and this was a image that's been getting a lot of airplay this year, Brock. Congratulations! But this was you talking at the International Astronomy Day on it, and I love this talk because you went through the all the procedures it takes to take these pictures, and it's not just. This is a nice quick pictures of the planet. There's so many steps and dealing with the distortion from the atmosphere, and it's quite wonderful what you have to do to get these wonderful images. Okay, so what is going on? And the Saturn is going around the sun with a 29-year year. It takes 29 years to go around the sun, and back in 2018, we could see the North Pole and the north face of the ring because, like, the Earth is tilted 33 degrees from the ecliptic, from the plane of the orbit of the Earth around the sun. The Saturn is tilted, something like 24 degrees, very similar. And so it's always pointing in the same direction with respect to the stars. But back in 2018, we were seeing the north. Here we are at 2025, and we're seeing those rings edge on. And as we go towards 2032, but even right now, we see just a little bit of the south of the plane of the rings, and they'll get bigger and bigger and then smaller and smaller till 2039. Okay, so that explains why there was this crossing, which was, I don't know, I saw it in many places that it was in March 23rd, 2025 was the day that you weren't going to be able to see the rings. They were going to be edge on. And I remember writing Brock, asking if he might have a chance to take a picture then. And he says, holy, it's very close to sunrise at that time of year. And it would be too close to the horizon. And it's just not worth even trying. It was not a good aspect. So there was no picture back when the ring was gone, and that, too bad. There were some other people that got a picture of it. And then Brock started doing all this amazing work on the 16-inch Polar and Chivens telescope up at the center of the universe. And on November 21, was this first light, Brock?
I don't know. Brock's
it was
still there.
first
There
light
he is.
for the electronics and stuff. Yeah.
Okay, so yeah, it's a 50 or 60-year-old telescope. But yeah, after all of the work that Brock and the DAO put into the telescope. That's the one that's in the little dome outside the center of the universe. He took this picture and said, yeah, there was another crossing.
Yeah, there's two. There was two in 2025.
And this bothered me. This bothered me a lot. First of all, how come there was a crossing in March? Everybody was talking about, not everybody, but the people that I read were talking about the crossing in March, and the one in November wasn't getting any press. Weird. But the other thing is, it didn't make sense that there could be two crossings. So, to talk about why I'm bothered about this, we're going to talk about cubic equations. Yay! Everybody loves cubic equations, right? So we're going to go to this link. And so a cubic equation has a constant, and so just for people to remember, I know people don't like equations. I love equations. Anyway, the x-axis is horizontal, the y-axis is vertical, and we have y is equal to some function of x. If it's a cubic, then there's a constant, a linear term, a squared term, and a cubed term. Okay, that's why it's called a cubic equation. And with this app, you can move these things around. So D is that constant there. A is the linear term. B is the quadratic term. C is the cubic term.
Oh.
See, oh, I got it backwards. A is the cubic term. C is that. I was wondering. That wasn't looking right to me. Anyway, so it's called an odd function, and an odd function starts from if negative x gives a very large negative number and positive goes very positive, then it's called an odd function. We can talk about this later on, but the important thing about an odd function is it crosses the x-axis an odd number of times, except if, well, it can cross it once, for example, like this. Okay, see, so that would be like one crossing of the seeing the tilt of Saturn just once. But you can get two if you just are like, let's get it right, like that. Anyway, let's go back to my presentation. Somebody in Cloudy Nights actually plotted up what the tilt of Saturn is. And I should have thought of this. The big 29-year cycle is modulated because we're not looking from the sun. We're looking from the Earth. So let's see, the Saturn is about 9 or 10 astronomical units from the sun. Okay, Earth is 1 astronomical unit. So we're going back and forth about 10%, 1/10 of the way to Saturn every year. And that modulates this big cycle of 29 years. And that's that wibble that we see. And the arrow here is pointing to November of 2025. And it didn't actually cross. It's about, this is a blow up of that. And you can see it came up to about 0.4 of a degree, which is pretty darn close to zero. So first of all, I added Brock's most recent picture of Venus to the rest and added its date. And then in CorelDRAW, I just drew an ellipse around the ring each time and took the ratio of the long axis to the short axis, took the arctangent, lots of you don't want to even know about your trigonometry, but it's really good because then you can see what angle it's at. And I have to tell you, I cheated on this last one. I couldn't possibly measure that, but I know what the answer is, so I wrote it in. Cheater, lack scientific integrity. And here is where I plotted them. And this is, Brock, how I knew that you gave me the wrong dates. Because you thought this one was in 2021, the first one. And so everything plotted off, and I was thinking, oh boy, there's something weird going on. But so when I went to take a look at when you actually took the pictures, and they were just off by a year, then it's remarkably, it works really, really well. Anyway, so in 2025, there was one crossing and one near flattening out. But all you have to do is wait 14 years and we get 3 crossings. And this will make Bill really happy because it's during those crossings that you can see transits of the moons on the surface of the planet. And there are these wonderful pictures that, I mean, especially Hubble took some beautiful pictures from the, I guess it must have been from 2009, where you see the moons just hovering above or below that disk. They're beautiful pictures. I should have brought one in. Anyway, so it's going to be just fantastic in 2039. Okay? Hold your breath. That's my story.
Yeah, Brock's going to take another picture.
I put in links to the series. I've also added one from September, which wasn't on Zenfolio, but it was in Astrobin. So, Randy, the minima, like you showed like a crossing, and then it went down and back up again in sometime this year. When was that minima?
Sorry. Let me go to the slide and then we can talk about it. Is it? No, I didn't do the right thing. Sorry, I have to go share first. Share, and it's trying. Okay, and so which slide are you talking about?
The one that shows the curves with the wavy lines. And then there was sometime this year, there was a minima. Like
it was supposed to be, I think it was March 23rd by
March 23rd.
No, the crossing. I'm talking about a minima, not the crossing.
Okay. Yep.
The bottom of that.
So this is a blow up of it. So the actual minimum or closest approach to zero was November 28th.
Okay, and then what I meant by minima was a low point on the graph, not the.
Oh, okay.
So
this guy here.
Yeah. When was that?
Well, let's say it was
you interpolate it
like
maybe
August, September's. We'd have to take a look.
Because I put a link in the chat of the picture that I took on September 10th.
Okay,
which is actually showing quite a bit.
Let's pull that up. Come on. I go zoom. I saw it.
We're seeing your desktop right now, Randy.
That's good. Now, where did my Zoom window go? Do I go here?
You can Alt Tab maybe to get to your Zoom session.
Oh lordy!
If you Alt Tab, you'll get to your session.
It doesn't do what you want it to do. Show meeting. There we go. And now, is it this first click or the second one?
Well, the second one is the individual Saturn image. The first one is the series with the new one at the end of it.
Oh, here we are.
Okay. So that is a better job than what I did. That's it.
And that's not the one from the 16. That was one I took with that was one from September 10th. So that would
Okay.
have been,
previous to the other one.
yeah,
And so if I click on this guy, then we'll get just a picture of it.
yeah.
Okay,
Wow.
and you convince yourself that the one that goes behind Saturn is on the bottom now, as opposed to all the other ones where they were on top. So we're seeing
Mhm.
in this guy, we're actually looking at the southern face of the ring. That's wonderful, and it is clearly larger than the picture you took in November.
Yeah.
That's really cool. Thank you. That's fantastic. So it works.
That's great. And a big reminder, I mean, Saturn's still visible. So go out and have a look at it when it gets clear.
And it's an evening star these days, is it?
It
Right?
is. Yeah, kind of. Yeah, I'm pretty sure. Yeah, it's in the evening. Or 10, 11, maybe, something like that. Neptune's nearby too. So if you've never seen Neptune, that's one way of locating Neptune relatively quickly. Well, that's great. Well, thank you very much, Randy. Is there anything else for people to talk about tonight? I don't really see anybody. Chris, do you see anybody on the screens?
No, it looks good. Excuse me.
Okay. Okay. Well, if there's nothing else, I look forward to seeing all of you on Wednesday at the meeting at UVic. That's definitely going to be an interesting thing of local information, local astro lore. And I'm hoping, Reg, I hope, are we going to get out to the VCO soon?
I think so. I think it's going to be pretty good towards the end of the week.
Yay!
Yay. Well, that's great. Or observe on your own. Anyways, thank you so much to all the presenters tonight and all the announcers. Looking forward to seeing you guys next week with Jeff. Okay, good night.
Thank you all. Thank you all.
Bye.
Really, really interesting.